Welcome to Summarize Science. Today we are looking at a major breakthrough in the world of computer vision called gaze estimation. Gaze estimation is essentially the process of teaching an AI to figure out exactly where a person is looking just by analyzing a picture of their face. It sounds simple, but it is actually incredibly difficult because real-world factors like shadows, messy backgrounds, and different head angles constantly confuse standard AI models. Most existing systems struggle to separate the important details of the eyes from the noise of the environment. To solve these problems, a research team developed a new framework called GMGaze. GMGaze is designed to be context-aware, meaning it doesn't just look at the eyes in isolation. The researchers utilized a powerful AI model called CLIP, which was originally trained to understand the relationship between images and text descriptions. One of the clever tricks they used is creating semantic prototypes. These act like categories that help the AI specifically identify things like the current lighting level or the angle of the head. By explicitly labeling these factors, the model can disentangle them from the gaze information, making the final prediction much more accurate. The model also handles visual data in a unique way by mixing big-picture views with tiny, high-resolution details. While many systems wait until the very last step to combine these different scales of information, GMGaze does it right at the beginning to prevent any data loss. Perhaps the most advanced part of this model is the mixture of experts architecture. Instead of one single brain trying to solve every problem, the system uses a team of specialized experts that turn on or off as needed. For example, if a face is partially hidden in shadow, the AI can route that specific data to an expert module that is specifically trained for low-light conditions. This makes the processing much more efficient because the AI only uses the computational power it needs for a specific task. They also added a feature separation loss during training, which forces the different experts to stay unique and not overlap their work. To prove it works, the researchers tested GMGaze against several top-tier AI models across 4 major public datasets. The results were impressive, with the model outperforming previous records in nearly every within-domain test. It was particularly successful in cross-domain evaluations, which is where an AI is tested on a group of people it has never seen before in a new environment. Even on the most challenging datasets, GMGaze reduced the angular error of its predictions significantly compared to older methods. In these visualizations, you can see how closely the red arrows, representing the AI's prediction, match the green arrows, which are the actual gaze directions. Even when faces are turned to the side or the lighting is harsh, the system remains remarkably steady. The researchers also analyzed how the model handles image quality issues like blurriness or low resolution. Because it relies on robust semantic clues from CLIP, it manages to stay accurate even when the input image is quite grainy. To recap, GMGaze succeeds by using context-aware experts to handle the messy reality of the world. It solves the old problems of information loss and environmental interference while remaining computationally efficient. In the future, this could lead to more responsive virtual reality, better accessibility tools for those who control devices with their eyes, and even smarter safety systems in cars. By making gaze tracking more robust, we are one step closer to more natural interactions between humans and machines. Thanks for watching Summarize Science.